Hello, everyone. This is Alex, and welcome to the mathleague.org YouTube channel. We'll be talking about Sprint Problem 28 from the March 2021 high school test 12106. So in this problem, we have, a circle omega with diameter 10 and a point C with AC equals 6. Well, what do we know about points that lie on the circumference of a circle? So here's a diagram to illustrate what we have, right? If we try connecting C and B as we've done in the diagram, well, look at that. Angle ACB, that's up there. That's 90 degrees because of Tolly's theorem. So certainly ACB has to be a right triangle. And you know what that means, right? CB is going to be 8. Okay. Great. Now what? Well, now I have this in-center, that's the point I, of our triangle ACB. Okay, and what else? Well, we're told that line segment CI intersects omega, that's the circle, again, this time at a different point D. And we want to find the area of ACBD. Where could we possibly start? Well, for one thing, we know this mystery point D has to lie below the diameter AB, because the in-center is the intersection of the internal angle bisectors, and because of the angle bisector theorem, we know the intersection of that bisector with AB has to lie on AB, not outside, right? So that pretty much tells us that the area we're looking for is the sum of the areas of ACB, that's just 24, and ABD. So now it suffices to figure out what the distance from D to AB is, since we already know that AB is 10, and of course the AC is 6. Because D lies on CI, which is the angle bisector, well, we just need to figure out what the slope of CI is. So we can say that CI will intersect AB at some point. Let's call it P, which is lying on AB, where the ratio of AP to BP is 6 to 8. So perhaps we can go ahead and label them as 6x and 8x for now. So that means that, well, 14x is 10, so x is 5/7, and AP is 30 over 7. So, okay, we can just, looks like we can just go ahead and immediately replace them with 30 over 7 for AP, right? And 30 times 4/3, that's 40 over 7 for PB, right? By the angle bisector theorem. And since the altitude of this triangle ACB down to, let's call it, let's just go ahead and draw the altitude real quickly. Let's call that foot F. We know that this altitude CF is going to be, well, the area of ACB is 24, right? And the base length is 10, therefore CF has to be 4.8, and that means AF is going to be 3.6. So now you can subtract 3.6 from 30 over 7. You get that FP is going to be, I'm going to write this in a separate thing over here. FP should be 24 over 35, right? Okay, so now what's our slope of CI, which is the slope of CP? Well, that's just going to be, let's see, the slope of CP is minus 24 over 5. It's a minus because we're going down. Divided by 24/35, that should just be minus 7. Perfect. We also need the y-intercept if we're going to figure out where a point D lies in relation, right? So we'll go ahead and generalize here a little bit. We're going to say that AB coincides with the x-axis in the plane, right? So the y-coordinates are both 0. Right, and we'll just let A be the origin. So its x-coordinates are 0, and C should be the point 4.8, no, wait, sorry, 3.6, comma 4.8. So now we can actually determine what the equation of CI is, because we also know that P should be 30 over 7, comma 0. And from this, we get that the equation of line CP is minus 7x plus 30. So now we want to find out where this intersects the circle. In other words, what our point D is. Okay, this is just algebra from here on out. Because now, well, we need the equation of the circle, right? Well, that's going to give us, it's centered at 5, 0, and it has radius 5. So it's going to be x minus 5 squared plus y squared is equal to 25. Plug in y equals minus 7x plus 30. that will give you x squared minus 10x plus 25 plus 49x squared minus 420x plus 900. That's 25. Simplify, you get 50x squared minus 430x plus 900 is 0. Well, that's just a quadratic that we can solve to obtain x is either 3.6 or 5. Now, we only want one solution, so we have to eliminate one of these. Which one makes sense? If we pick x equals 3.6, then we'd have y equals, well, that's 4.8. Unfortunately, that doesn't work because d should lie below the x-axis. The y value should be negative. So that leaves us only with x equals 5. And x equals 5 it is because we get y equals negative 5, and that works. So d should be equal to 5 comma negative 5. So altogether, the length of the altitude from AB to point D is just 5. And so the area of ABD is 25. And now we can add that to the area of ACB, and we conclude that the area of ACBD is the area of ACB plus area of ABD. That's 24 plus 25, which is 49. And we're done.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.